Welcome back again to this tutorial. So this is the second question. So I'll read it. It says a particle moves along the x-axis from x is equals to 0 to x is equals to 5 meters under the influence of a force given by the following equation, that is F is equals to 7 minus 2x plus 3x squared. So this question wants us to find the work done in the process. So now in this case, we have a force, a variable force. So how do we go about this? So solution, how do we go about this? So now we realize that the force here, force is variable. So therefore it brings in the element of integration. So it will be right if we say that for this question, you're going to say that work done is equal to the integral from x1 to x2 over f dx. Now f here is variable, and changing the displacement is what we call dx. And we were given the equation as f is equals to 7 minus 2, sorry, to x plus 3x squared. So what we are going to do is integrate this equation here. So again, remember we were told that x1 is equals to 0 and x2 is equals to 5 meters. So I'll rewrite this equation. So you have work done is equals to the integral from 0 to 5 of 7 minus 2x plus 3x squared. So we're going to differentiate this equation. Again, sorry, integrate. So again, sorry. Remember integration, this is what you usually do. So if you have a value raised to n of dx, then that can be integrated in such a way that we add 1 to this power so that we have x raised to n plus 1 divided by the power that you have just found. So you have n plus 1. So always remember this when you are doing integration. So let's go back here. So work done is equals to, when you integrate these are constant. So we have 7x minus, so we have 2 as a constant. Then we have x squared over 2. Then plus, so we have 3 as a constant. So this will be x cubed over 3. So, but remember, we are differentiating from 0 to 5. So the whole of this from 0 to 5. So now we are going to say work done is equals to, so we integrate x, so we substitute the value of x in this equation by 5, so that we have 7 times 5 minus, so if this goes with this, so it will remain with 5 squared plus, so this goes with this, so we are remaining with 5 cubed. Now again, whatever you get here, you subtract the value that you get when you substitute 0 in the whole of the equation. So you'll have 7 into 0 minus 0 squared plus 0 cubed. Now basically this end will give you 0. Now work done is equivalent to, so this is 35 minus 25 plus 125 minus 0 on this other side. So the whole of these is measured in joules. So the units are in joules. So work done is equivalent to, so if you subtract, if you do the arithmetics here, you'll be able to arrive at 135 joules. So guys, that is the work done for this particular, by this particular particle. So that is how we go about that question.